All right, so ready to dive into some really cool AI research. Today we're talking about large multimodal models, or LMMs, and specifically how to make these AI systems, especially the smaller ones, way better at reasoning. Imagine like you have a compact LMM, say 3 billion parameters, and you want it to like tackle complex problems that involve, both images and logic. It's not exactly a walk in the park, right?
Yeah, it's like trying to cram a supercomputer's brain into, like a tiny pocket calculator.
Wow, yeah, I like that.
Yeah, the main challenge is how to boost those reasoning abilities in these, smaller LMMs. And it's tricky because those old school methods, like that rule-based reinforcement learning, they've worked great for language models, the ones that just deal with text, but they don't quite translate, as smoothly when we bring images into the mix.
Okay, so I'm curious, why is it so much harder when we start dealing with visuals?
Well, one of the biggest roadblocks is just the lack of data. Trying to find a good amount of examples of those complex reasoning problems that involve both images and text. It's like finding a needle in a haystack.
Yeah,
Most of the data sets that are out there now, they focus on basic visual stuff, like just identifying objects. It's not the hardcore problem solving we're talking about.
so it's not just there's a cat in the picture. It's more like, what's that cat doing? Why is it doing that? What might happen next? And all of that is connected to some text-based info.
Yeah, exactly. And there's another interesting thing here. The research, it actually suggests that, if you overload the model with too much visual data while you're training it, it can actually weaken its ability to just solve basic text-based logic problems. It's kind of like the model's forgetting how to think straight when it gets bombarded with all these images.
Wow, that is wild. So how do the researchers tackle that?
It came up with this really neat framework called LMM-R1, and it uses a clever two-stage process to really boost reasoning in smaller LMMs.
Okay, I like it. Break it down for me. What's stage one all about?
Stage one is called Foundational Reasoning Enhancement, or FRE, and it's all about laying a really strong foundation in logic.
Makes sense.
So they use rule-based reinforcement learning for this, but the cool part is they train the model just on text-based data at this stage. No images yet.
Oh, interesting. So it's like giving the model a crash course in Logic 101 before throwing in any visual distractions.
Yeah, you got it. And this approach is pretty smart because it tackles that data scarcity problem head on. There are already tons of text-based data sets out there that we can use for this stage. Plus, by keeping the focus on text-based reasoning in the beginning, they protect the model's core logic skills from getting, kind of diluted by all that visual data.
Got it. So it gets a strong foundation in logic using data that's already out there, and it doesn't lose those text reasoning skills in the process. Win-win, right?
Yeah, for sure.
But what happens in stage two? What's next?
Stage two is where it gets really exciting. This is what's called the Multimodal Generalization Training, or MGT. And this is where they bring in the visual element. So now the model has to take all those newfound reasoning skills and apply them to a bunch of different multimodal tasks. Think, solving geometry problems that have diagrams, or understanding those scientific questions that come with visuals. Now the model have to connect the dots between its logical thinking and the visual world.
Okay, so stage one, it's boot camp for logic, and then stage two, it's deployment into the field.
Right, way to put it. And they tested this out in two key domains: general multimodal reasoning, which is kind of what I just described, and also agent-related reasoning.
Wait, agent-related reasoning. What does that involve?
So think of it as the model being like an agent acting in a virtual world. It could be playing a game like Sokoban, where it has to push boxes to specific spots, or even like navigating a virtual football game, making decisions based on what it sees happening on the field. So the model has to take in what's around it, plan out its actions, and then actually do those actions, all while using the reasoning skills it learned in that first stage.
Wow, that's a big jump going from logic puzzles to playing virtual football. So did this two-stage approach work? I mean, like actually work?
The results were really impressive, especially given how relatively small the model is. In that MGT stage, they saw big improvements in performance in both domains. Like in geometry tasks, LMMR1 could actually use the Pythagorean theorem to solve problems that completely stumped the baseline LMM.
So it's not just like theoretically better at reasoning, it's actually cracking those problems it couldn't solve before.
Yeah, exactly. And remember, we're still talking about a 3 billion parameter model. And in some of those agent-related tasks, like the Sokoban game, it actually did just as well, or even better than those much larger models.
Wait, hold on. It was out bigger, more complex AI on these tougher tasks.
That's right. And it's not just about performance either. LMR1 is also really efficient with data. By starting with that easy-to-get text-based data for reasoning, they bypass the need for those huge labeled multimodal datasets, which can be super time-consuming and expensive to create.
So they found a shortcut to multimodal intelligence.
In a way, yeah, it shows how powerful it can be to build that strong foundation in reasoning first, even if it's just in the text domain initially. But here's where things get even more interesting.
Okay, lay it on me. I want to hear more.
Remember how we talked about that potential downside of focusing just on text-based reasoning, that worry that it might hurt the model's performance on those purely visual tasks? Well, at first, that's exactly what happened. During the FRE stage, there was actually a little dip in how well the model did on tasks that just involved images.
So all that logic boot camp made it a little less visually savvy.
It might sound counterintuitive, but yeah. However, once they went on to the NGT stage and started bringing in that visual data, something really cool happened. The model didn't just recover those visual capabilities, it actually blew past its initial performance on those visual tasks.
Wait, so by becoming a logic whiz first, it could then apply that logic to the visual world even better.
Exactly. There seems to be a really powerful synergy happening between those two stages. The model's beefed up reasoning skills from that FRE stage actually helped it learn and generalize from the visual data in a much smarter way.
That's amazing. 'Cause, like, the logic training wasn't just teaching it how to reason, it was teaching it how to learn visually.
You got it. And this was really clear in those geometry tasks where the model seemed to develop a much deeper understanding of those geometric relationships.
So we're not just making these smaller LMMs better at reasoning, we might be unlocking a whole new level of visual understanding as well.
It's definitely a possibility and one that opens up some pretty exciting paths for future research.
Okay, before we get too lost in the future, let's bring it back down to earth with a specific example. Can you walk me through how LMMR1 tackled one of those tricky geometry problems?
Sure, let's look at that example from figure 1 in the paper where the model had to figure out the slant height of the cone. So it gets this diagram with some measurements and it needs to work out the missing piece. Now the baseline LMM, the one without that special LMMR1 training, it totally messed this up. It got the slant height wrong, which obviously led to the wrong answer.
Tripped at the first hurdle?
Yeah, basically. But with LMMR1, the model took a much more systematic approach. It figured out that it needed to use the Pythagorean theorem to find the slant height. It went through the problem step by step, pulled the right info from the diagram, and got to the correct answer.
So thanks to that logic bootcamp in stage one, it knew exactly what tools to use and how to use them.
That's right. And remember those agent-related tasks, like playing Sokoban?
Oh yeah, the virtual football.
Well, it's not quite football in this case, but the idea is the same. This 3 billion parameter model, after going through the LMM-R1 training, it actually matched or even did better than much larger models on these tasks. It learned to strategize, plan, and actually carry out actions in these dynamic visual environments. It's showing a level of reasoning that people thought was out of reach for a model this small.
This is amazing. It's like the little engine that could.
It really is, and what makes it even more impressive is that they did all this without needing mountains of data. That data efficiency is a total game changer.
So if I'm getting this right, LMMR1 is like this recipe for creating AI that can reason across both text and images, even if you don't have a ton of resources. That's got huge implications, doesn't it?
It absolutely does, and it brings up some really interesting questions about the future of AI, but we'll dig into those a little later.
Okay, can't wait. So we're back and ready to dig a little deeper into the potential impact of this LMMR1. I mean, we've seen that it can really make smaller LMMs much better at reasoning, even beating out those bigger models in some cases. So what does all this mean for AI down the line? What kind of real world stuff are we talking about here?
The possibilities are, well, pretty much endless, really. I think one of the most important implications is that we could really open up access to advanced AI to, well, more people. If we can get such amazing results from smaller, more efficient models, it means that even researchers and developers who, maybe don't have the resources to train those massive resource-heavy models that need supercomputers and just tons of data, they can still be a part of this.
So this could even the playing field, kind of. Allow smaller teams and companies to actually contribute to AI's development.
Exactly. We could see this huge surge in innovation, speeding up progress in all these areas where multimodal reasoning is super important. Think robotics, healthcare, education. Imagine having these smaller, more specialized LMMs that are built into everyday devices that can actually understand and interact with the world around us in ways that, well, we've only dreamed of up until now.
It's a pretty exciting thought, right? Instead of AI being this exclusive club for the tech giants, We could see AI-powered tools and apps developed by smaller groups, startups, even just individual researchers. It's like the open source movement, but for AI.
That's a great way to put it. And this kind of accessibility could have a massive impact on how AI is integrated into our lives. But let's get down to brass tacks here. Where do you see LMM-R1 having the most impact, like in the short term?
Well, scientific research comes to mind right away. I mean, so many fields like biology, chemistry, they deal with super complex images and text. Imagine an LMM that can analyze microscope images, read and understand research papers, and even help scientists come up with new hypotheses.
It'd be like giving scientists a super-powered research assistant. The possibilities for speeding up discoveries are just immense. Think drug development, disease diagnosis. LMMR1 could help researchers go through those mountains of data, find hidden patterns, and uncover insights that would have taken years to find manually.
That changes everything. And it makes me think about personalized medicine. What if there was an AI system that could analyze your medical history, your genetic information, even your lifestyle, and then create a treatment plan that's just for you?
The possibilities are incredible, right? And it's not just healthcare. Education is another area where LNM01 could really shake things up. Imagine textbooks that are interactive and adapt to each student's needs. They could give personalized explanations, offer visual aids, and just make learning way more engaging and effective.
It'd be like having a personal tutor for every student. No more one-size-fits-all teaching. We could create learning experiences that are really tailored to each student's strengths and weaknesses.
That's the idea. And it wouldn't just be for students either. Imagine LMMs that help professionals stay up to date in their fields. They could analyze new research, industry reports, even those real-time data visualizations. It's like having a personal mentor available 24/7.
It's amazing to think about the potential for lifelong learning and professional development. We could all become experts in whatever we do, constantly learning and adapting to all the changes happening in the world around us.
Exactly. And this brings us to another exciting area, robotics. Right now, robots are really good at those repetitive tasks, especially in controlled environments. But if you add some complexity, a need to adapt on the fly, they struggle. They just don't have that common sense we human have.
So they're missing that ability to really understand the situation, the context, and then make a judgment call even if they don't have all the information. Like they can't improvise.
Exactly. And this is where LMMR1's approach could be a game changer. Imagine training robots using that same two-stage process. First, giving them that strong logic base with text data, then expanding that reasoning ability to the real physical world using visual input and interaction.
So instead of programming a robot to do task A, then task B, you teach it to think about how to achieve a goal, even if the environment's unpredictable or messy.
You got it. It's like teaching a robot what fragile actually means. You wouldn't just show it a bunch of breakable things. You'd first explain the concept through language, then show it what happens if fragile things aren't handled carefully.
So you're not just doing object recognition, you're teaching it about consequences and cause and effect in the real world. That's huge.
Huge is right, and having that deeper understanding could lead to robots that are way more adaptable, better at working with humans, and safer to have around in all kinds of different places.
Okay, so now I'm picturing robot assistants that don't just follow instructions, but they can anticipate what I need and even help me avoid making dumb mistakes.
Exactly, and think beyond just having help around the house. Robots could assist in search and rescue efforts, navigate disaster areas, work side by side with scientists in labs, places where being adaptable is critical.
Like LMMR1 could be the key to making robots truly intelligent partners instead of just sophisticated tools.
It's an exciting possibility for sure, one that could change how we work, live, and interact with technology on a really fundamental level.
But there's got to be a but here, right? With this much potential, there have to be some challenges too.
You're absolutely right. Just like with any powerful technology, we need to be thinking about the ethical side of things and the potential downsides that we need to address before they become problems.
We talked about making sure these AI systems are in line with human values and having things like transparency and accountability built in. What are some other concerns that come up when robots start getting this improved reasoning capability?
Well, job displacement is the big one. As robots get better at doing things that humans currently do, some jobs are going to be lost. We need to be prepared for this shift and figure out how to handle it as a society.
So it's not just a tech issue, it's an economic and social one as well. We need to think about things like retraining programs, new types of jobs that might pop up, and how to make this transition fair for everyone.
Exactly. These conversations need to be happening right now, not later down the road. And of course, there's always that risk of things being misused. Any tool can be used for harmful purposes, and this technology is no exception.
So along with all the excitement about what LMMR1 could make possible, we need a good dose of caution and some careful planning.
I couldn't agree more. We need to think about the full range of possibilities, both good and bad, and make sure we're working toward using these advancements for the benefit of everyone.
It's about striking a balance, pushing the limits of what we can do with AI while also being careful not to cause any unintended harm.
That's exactly right. And I think that's a great point to pause for a moment. We've covered a lot from the nuts and bolts of how LMMR1 works to how it could completely change different fields and all the ethical questions that come along with it.
It's been quite a journey. I feel like we've barely scratched the surface of what LMMR1 and this whole new wave of multimodal AI are capable of.
The research is moving incredibly fast, and I'm personally super excited to see what comes next. This is a really transformative time for AI, and the decisions we make now are going to shape the future of this technology and how it affects our world. But we'll come back in just a bit to talk more about the potential future of multimodal AI. Hang tight.
All right, welcome back to the deep dive. We've been exploring this pretty amazing world of LMMR1, that framework that's making smaller, large multimodal models so much better at reasoning. It's really all about combining visual understanding with that logical thinking. And man, the possibilities they're mind-blowing.
Yeah, they really are. And what's really exciting is how this research could actually like branch out and affect other areas of AI, not just LMMs.
Okay, now you got me curious. What other parts of AI could LMMR1 influence?
Well, robotics is a big one. Right now, robots they're great at doing those repetitive tasks, especially in environments that are really structured. But when things get a little more complex, when they need to make decisions on the fly, they tend to fall apart. They don't have that common sense that we humans kind of take for granted.
Yeah, they're missing that ability to look at a situation, get the context, and make a judgment call, even when they don't have all the info. It's like they can't improvise.
Right, exactly. And this is where LMMR1's approach could be, well, revolutionary, really. Imagine if we could train robots using that same two-stage process. First, give them that solid grounding in logic using text data, and then take that reasoning ability and extend it to the real world, the physical world, through visual input and interaction.
So instead of just programming a robot to do this, then that, we're teaching it to actually think about how to reach a goal, even in an environment that's messy and unpredicted.
Yeah, that's the idea. It's like teaching a robot what fragile means. You wouldn't just point at a bunch of delicate objects, right? You'd first explain it through language, then show it what happens when fragile things are dropped or mishandled.
So we go from simple object recognition to understanding consequences, cause and effect in the real world. That's a huge jump.
It is a really big jump. And that deeper level of understanding, well, it could lead to robots that are much more adaptable, better at working with us humans, and safer to have around in all kinds of situations.
Okay, now I'm picturing these robot assistants that don't just follow instructions, but they can anticipate my needs and even help me avoid making, dumb mistakes.
Right, and think beyond just helping out around the house. Imagine robots that can assist in search and rescue missions, navigate disaster zones, or work alongside scientists in labs, those places where being adaptable is so important.
It's like LMMR1 could be that missing piece that makes robots truly intelligent partners, not just fancy tools.
That's a really exciting thought, one that could totally change how we work, how we live, and how we interact with technology in a really big way.
But there's always a but, right? I mean, with so much potential, there might be some challenges that come along with this.
You're absolutely right. Just like with any powerful technology, we have to think about the ethical side of things and the potential downsides, and we need to address those before they turn into real problems.
Yeah, we've talked about making sure these AI systems line up with human values and making sure there's transparency and accountability built in. What other concerns come up when robots start having this, improved reasoning ability?
Job displacement is a big one. As the robots get better at doing the things that humans do now, well, some jobs are going to disappear. We need to be ready for that kind of shift as a society and figure out how to handle it.
So it's not just a technology problem, it's an economic and social one too. We need to be thinking about things like retraining programs, new types of jobs that might emerge, and how to make that transition as fair as possible.
Exactly. And these conversations need to start happening now, not later. And of course, there's always that chance of things being misused. Any tool can be used for harmful purposes, and this technology is no different.
So it sounds like, along with all the excitement about what LMMR1 could make possible, we need a good dose of caution and some careful planning.
Absolutely. We need to consider all the possibilities, good and bad, and make sure we're using these advances for good to benefit everyone.
It's like we need to walk this tightrope between pushing the limits of what we can do with AI while also being careful not to cause any harm along the way.
That's a great way to put it. And I think that's a great place for us to wrap up our deep dive today. We've covered so much from the inner workings of LMM-R1 to how it could revolutionize all sorts of fields to all the ethical questions that come with it.
It's been a wild ride for sure, and I feel like we've only just scratched the surface. LMMR1 and this whole new wave of multimodal AI can actually achieve.
The research in this area is moving at an incredible pace, and I'm personally excited to see what breakthroughs come next. This is truly a game-changing time for AI, and the decisions we make now are going to shape the future of this technology and how it affects all of us.
To everyone listening, thanks for joining us on this deep dive into the world of LMMR1. We hope you found it informative and thought-provoking. And as always, we encourage you to keep learning, keep asking questions, and be a part of the conversation as we explore this new and uncharted territory. Until next time, keep on diving.